Hello kids, so today we are going to see a problem based on critical velocity. Okay, so let's start with the problem. The problem goes like this: how much time a satellite in an orbit at height 35780 kilometer. This is an important information. Okay, we know that this height is of high Earth orbit, right? And we know something about this height. Okay, when the height is 35780 kilometer, then the time period was approximately 24 hours. Remember, this is in your textbook, right? Okay, so this is an important information. If the mass of the earth would have been 4 times its original mass, so what more information is given? The mass of the earth would have been 4 times. So if mass in case 2 equals to 4 times the original mass, okay, how much time? So we have to find the new period of revolution. So what is the first period of revolution? This one, right? Okay, so this is the scenario that the height, suppose this is the earth, okay, this is the HEO, okay, and here is our satellite, something like this. Okay, height is given, this is our radius. By the way, what is the radius of the earth? 6400 kilometers. Okay, and you know what, this is our r, right? R equals to r plus h, right? So r is 6400 plus h 35780, right? Calculate this, how much? 0 8 6 and 6 12 kilometers, something like this, right? Okay, so let's solve this, by the way. Okay, what is the formula for critical velocity? So critical velocity's formula is square root of gm upon small r plus h, right? Okay, so think about this. If suppose in case 2, okay, so critical velocity 2 will be what? Square root of g m upon r plus h, this will be m2, right? So why haven't we written 1 and 2 here? Because in the question, remember that in question the radius cannot be changed, right? Radius of the planet is same, it's constant. Okay, height is given, so that is the same, constant, right? G is always same, that is constant. What changes? Whatever is changing, right? Changing is m2, correct? Okay, so if we divide this, suppose we have this equation 1 and equation 2. If we divide equation 1 by equation 2, what we get is critical velocity in case 1 upon critical velocity in case 2, square root of g m r plus h upon square root of g m2 r plus h, common root, so this is gm2 r plus h and r plus h, right? This goes off, this goes off, and what we get is critical velocity in case 1 upon critical velocity in case 2 equals to square root of m upon m2. But you know what m2 is? M2 is 4 times m, right? So critical velocity in case 1 upon critical velocity in case 2 is square root of m upon 4m, and this goes off, this goes off, right? Okay, so what we get is critical velocity in case 1 upon critical velocity in case 2 equals to square root of 1 is 1, square root of 4 is 2, critical velocity in case 2 is 2 times critical velocity case 1. This is important. Okay, and now we go ahead further. Okay, we also know that critical velocity is also velocity is distance upon time, so it's 2 pi r upon time period. Okay, what is this r plus h, right? Okay, so critical velocity in case 2 equals to, okay, acha, one more thing, this 2 is constant, pi is constant, small r is constant, what changes is t, right? Okay, so we can also write like this. Let's move this, okay, critical velocity is inversely proportional to, wow, what an effect, I wasn't aware that this was here. Okay, so critical velocity is inversely proportional to time period. This is important too. Why? Because see this, as we move to a particular height, as we increase the height, the time required for a complete revolution will also change, right? So the velocity will also change. Okay, so critical velocity is inversely proportional to time period. So by this, critical velocity 2 is inversely proportional to time period 2, and critical velocity in case 1 is inversely proportional to time 1. If we divide these two, right, okay, suppose this is equation 3 and equation 4, if we divide 3 by 4, what we get, critical velocity in case 2 upon critical velocity in case 1 equals to 1 upon t2, 1 upon t1, and we know denominator moves, this is t1 upon t2. So critical velocity 2, you know what, critical velocity 2 is related with critical velocity 1 by this equation, right? Critical velocity 2 is twice that of critical velocity 1. So if we replace this, substitute that particular value, 2 times Vc upon Vc1, so t1 upon t2, so this goes off, so what we get is t1 equals to 2 times t2, right? Or we can also say that t2 is half of t1, and we know the value of t1, t2 is half of 24 hours. So what is t2? t2 is half of 24 hours, so 2 ones are 2 12s are, t2 is 12 hours, approximately 12 hours. Why approximate? Because t1 was approximately equal to 24 hours, so t2 is approximately equals to 12 hours. This is an easy way to solve this. One more method is there, but it's quite tricky. Okay, so better we'll go with this. Let's revise what we have done. Okay, we haven't used this, right, in this. Okay, so leave it. So question was that height is fixed 35780, and we know that this at this particular height time period is 24 hours. Okay, so h is given and t1 is 24 hours. Okay, what we did is we use critical velocities formula for critical velocity. Okay, critical velocity 1 equals to g m1 upon r plus h. vc2 is this, we divided this, critical velocity 1 upon 2, this denominator moves, went off, m1 upon m2, right, m1 upon m2, we substituted m2 equals to 4m, it was given, went off, so critical velocity 1 upon 2 equals to half, so vc2 is 2 times critical velocity 1. We are going to use this further. Then we derived something. Okay, we said that critical velocity is 2 pi r upon t, but all these three are constant. Okay, and therefore critical velocity is inversely proportional to time period. So critical velocity 2 is inversely proportional to time period 2, critical velocity 1 is inversely proportional to time period 1. We divided 3 and 4 and we got this. We substituted critical velocity 2 as 2 times c1 because we got it here, right? So we got t1 is half of t2 is half of t1. What is t1? 24 hours, so t2 is 12 hours. That's it. It's easy. We have to use the formula twice and we have to divide twice. Okay, so remember that. Do your best. Bye bye.